Aleksey, Nautilus is building the future of air freight. Before you build the future, can you share with our audience what the current state of the air freight market is?
The current state of the air freight market is actually in a very interesting place for the first time over the last decade. So obviously, we've all been through COVID. We kind of understand what that happens. And there was a huge scaling within air freight for capacity to help meet the demands of e-commerce and whatnot. And so actually coming off of COVID, there's still a lot of excess capacity on the air freight side. And so a lot of things that we were counting on as the company as we were scaling up, of course, have kind of changed. And so we had to maneuver our business to the post-COVID world, but it's slowly returning back as capacity. As far as, we're finally meeting demand and capacity is starting to normalize. There's still a huge gap within the orders of airplanes, as an example. So a lot of there's kind of like two airplanes in the world or types, as far as there's a dedicated freighter coming off the production line, whether it be a Boeing or an Airbus. There's also airplane conversions, taking existing passenger airplane, like an older model, and converting it. And it seems like the conversion market is doing really well, but still gaps in the supply chain are, even on the airplane side, are preventing the delivery of these, passenger to freighter conversions. And so as capacity is normalizing, the supply chains are still lagging. It feels like on ocean, air freight, and trucking. And so it's actually introducing more interesting challenges within the air freight business as far as dedicated freighter deliveries and supply and demand.
What impact is the changing supply chains? We're seeing a big shift globally, moving from China to Vietnam to India. Obviously, the infrastructure in India is not as advanced as in China or in Vietnam. What impact does that have on the market?
I think there is, as we're seeing, of course, geopolitical things shift. And I think that's where there's a huge change within the direction of where we're doing offshore manufacturing. A lot of those areas are just, they still depend heavily on ocean as being a kind of a logistical, the bulk of the logistical chain that they're used to. So there's actually not a lot of air freight infrastructure, whether it be at airports and warehousing, to help deliver dedicated air freight services. And so what that means, and I think in a global supply chain, is just it's moving slower as we kind of, first of all, shift to some of these other countries. And then on top of that is they're building up infrastructure on their side to help, move around larger goods, whether it be by ocean, ocean terminals, or by specifically even air freight to help accelerate some of those logistical challenges.
There's a plane currently in the sky as we speak. It's being tracked on FlightAware. It's the iPhone plane. It's been nicknamed. But the iPhone's coming from China, and there's people on FlightAware tracking this because people track planes, as Elon and various other individuals have found out. Are there historical routes for air freight, say from Shanghai to Los Angeles, Sydney to Shanghai, that are historic large volume routes for air freight?
There are. So what's really interesting about air freight in general is it carries 10% of the world's goods, but it carries 90% of the value of the world's goods. And so things like iPhones specifically, which are not a commodity, so technology, believe it, fashion is a really huge part of it, as well as perishables kind of represent some of the three big goods that are being shipped. And something over the last 30 years has happened, of course, is e-commerce. We can share a little bit more about that. But there's actually a very interesting kind of path that most air freighters would take. And they always travel from east to west, or sorry, west to east, I guess in our case. So example might be coming in from Shanghai or Shenzhen, which is a large manufacturing hub. They would actually, the bigger freighters like the 747s and the 777s, because they're so heavily loaded, they can't actually go directly into United States. They usually typically stop at Anchorage. And then they transfer to smaller airplanes, and then they would pick up more goods. And then they would either go to Ohio with some certain subset, or depending for which kind of companies they're going to, pick up more goods. And then after that, they would pick up on the Eastern Seaboard, which would be U.S. manufacturing. And they would finally deliver that to Europe. And then from Europe, they would take the European goods, deliver it to the Middle East. Middle East will be kind of another transfer point for fuel. And then that will be essentially then driven over to the Asian again. And so then it kind of circumnavigate the world essentially in one direction. There's, of course, I would say outliers like that. An Amazon fleet is very different, but most generally the dedicated larger freighters fly like that. Amazon tends to be more sporadically. There's nothing really scheduled, and it's based on supply and demand that's going on in the warehouses. But overall, it's that whole global singular path that air freight follows.
When did Anchorage, Alaska emerge as the logistic hub? Has it always been and nobody really talks about it, or is that a recent development?
Exactly right. So nobody really talks about it, but it's just one of those stops, especially on the larger airplanes. They're so heavily weighted compared to the passenger side of the business that they just have limited fuel. And so they have to make a stop. And Anchorage has kind of emerged as one of those very unique airports with a very large airfield. And especially if you look at like the global arcs coming in from Asia, you're still passing through Anchorage in Alaska. And so might as well stop there, pick up fuel, redistribute the goods, and then send them in the right paths and down south into the United States. And of course, we shifted into the eastern seaboard as well.
Where do you see Nautilus fitting into these flight patterns, or if you want to use a term that you use, paths?
So where Nautilus fits in is we kind of saw really two fundamental shifts over the last 30 years, and that's how the company started out. So the first one was the realization that it's really volume, not weight, that drives air freight designs. And so traditional Boeing and Airbus or tube and wing configurations, they cube out on volume before they top out on weight for most cargo. And specifically, that makes sense. You open up an Amazon box, it's halfway filled with air. And so this cubing out is a very interesting challenge that a lot of the passenger-focused airplanes just can't solve. And so when you couple that with also some of the bigger ways, like stopping up at Anchorage, you could actually design an airplane where you don't have to make that stop. You can do more direct connections. You can be more volumetrically outsized for rectangular pallets because there's a lot of corners within air freight today. And so there seems to be like a logistical hub, especially with technology emerging, e-commerce, that's really been driving and even perishables on a global level as the global supply chain that keeps getting so macro and I guess breaking down barriers, that there's a dedicated need for a freighter now. And so it seems like a small market for like a Boeing or an Airbus. It's actually a $280 billion market. But for a startup with a very, focused solution for air freight, it's a really nice niche to play in, especially if you're the only player that actually has a dedicated freighter solution.
280 billion is a very healthy market. Let's be honest with one another. It's a healthy market, and the way the consumer trends are going globally, online shopping is just going to continue to take off. Unfortunately for our friends in retail, I'm really sorry. The growth of online is just going to continue, and it's going to ship to us on boats, and it's going to ship to us on planes. You mentioned direct connections. What are the cost benefits of eliminating those stops? Because if you look at it, let's look at traditional passenger airlines. They love the hub and spoke model because they can put more individuals on the plane and fully optimize it. But if you're running an air freight, air cargo, I'm assuming you don't want to make very many stops if you don't have to. So what are the cost benefits of eliminating those stops?
It really depends on the route, but there's a couple of really interesting routes. As an example, like Frankfurt over to Shenzhen or Shanghai over Asia. So they even just that range alone, it's really heavy freighters, typically carrying about 100 metric tons plus of payload. A lot of it is perishables, as an example. So you need cold supply chain as well. And so they have to always make a stop, and that stop used to be actually in Russia. For just literally, they'd be on the tarmac refueling. They're still running the engines or have hookup for perishables, as an example. And that's 4 to 6 hour stop, then get them back in the air and things like that. And now with the war too, it's they have to make a bypass over to the Middle East to refuel. So it's even just those supply chains are getting more heavier. But yeah, I mean, specifically in perishables, and usually folks have mixed cargo on board. And if it's seafood, sometimes they put seafood on ice. And so that ice is just sitting there in a hot tarmac sometimes, and it's just melting away. And I've seen it many, many times where they come in and the seafood gets unloaded and they have to throw away half of it sometimes. And so especially when it comes to perishables, I think that's an important part of it. Things like electronics, iPhones may be the only exception because the demand is so high. It's a little bit different, but it's specifically on the perishable side that they're more cognizant of those stops.
The iPhones, they have to be cognizant because of the value on the plane. I don't remember the exact number, but that's a lot of money. Even though the iPhone sales are not great, I do not believe we're going to have the great iPhone cycle. I'll say that for the record. But you're right. Think about this from a security standpoint. And then the fact that the plane's being tracked, if you have the Lufthansa heist back from Goodfellas in the movie, you get a bunch of wise guys show up and knock a plane off. It's $1 billion heist. And guess what? It's going to be a lot easier to wash iPhones, even though they're trackable, than it is going to be to wash all that cash. Because you're going to go knock on every single door. I don't think so. But what type of distance are your aircrafts are you aiming to do? Are you building it based on routes? What type of distance are you trying to achieve?
So today we have kind of 3 products within our family of airplanes. The first one is a regional freighter connecting smaller regional airports to larger hubs. A good example might be Eugene, Oregon to Oakland, California for the nightly FedEx sort. So smaller airports, but moving that cargo in a nightly type of cycle, which is very time sensitive. And then, also connecting smaller regional, islands to larger chains. A good example might be the Japanese islands to the mainland islands. So that'll be the first product, the regional freighter, the Kona is what we're calling it. The second one is a Horizon type of platform that's meant around the 737, A320 market, about 30 tons of metric payload. And those will have ranges going in domestic United States, clear across, going into South America, connecting those smaller airports and kind of on a global level like that. And then finally, the larger airplanes can carry between 60 and 100 tons of payload Those are meant for trans-Pacific long-haul routes. The trans-Pacific long-haul routes are the most profitable routes in the world today, specifically just due to the value and the capacity is being moved from Asia over to the United States. So, of course, manufacturing and then the consumer side of it here in North America.
Will all your aircrafts have the blended wing design, or will that only be on certain aircrafts that you're designing?
All the family of airplanes have a blended wing body design. And what that allows us to do is for the same weight of airplane, we can open up 20% more volumetric space. And so solving that fundamental problem of essentially airplanes cubing out, the tube and wings. The second pieces of the puzzle is specifically strategic cargo-based sections, which we have patents for, where you can actually fit standing rectangular cargo and outsized machinery, things like GE9X engines for the larger airplanes are a big part of it, as well as temperature zones. And then the airplane itself is also 30% more efficient aerodynamically. And so the cost of goods and the shipment of goods, as well as the amount of volume of goods we can offer up, we can actually reduce the cost of moving goods by air freight by almost 2x. And that's a really big pain point for a lot of people, like as an example, like an Amazon on the fuel costs or the profitability as an example for folks like Emirates, which operate mixed fleets. So that fuel efficiency is a really big part of it, along with an increase in capacity.
Why have we not seen more blended wing design from a Boeing or an Airbus in the market today, in your opinion?
There's been a lot of stigma, both from Boeing and NASA, about the blended wing body. And specifically, when they studied it in the late 1990s, early 2000s, they identified a lot of challenges with it, specifically complex flight control systems, unique pressurization that is required to it. And so they kind of Boeing internally killed the idea of it. And so, I mean, they've been looking at it from a research perspective, but not particularly seriously. So I think there's that whole perception of it, and then also the airlines were kind of conservative during those timeframes as well. So, betting on a brand new design that's never been tried, true, and tested and built in full scale definitely feels like a risk when, look, we have this tube and wing configuration that we know exactly how to load it up, the infrastructure that is required for the ground support equipment. And so the moment you start changing that puzzle, I think there is even within the airline stigma, a little bit of a challenge. But with the rise of e-commerce and increased competition, the increase in fuel costs, I think for the first time ever, large airlines are starting to think about what could we do different. And then also the normalization of the large technology projects such as ours, with people like SpaceX, Tesla, and there's a couple of other examples. I think the capital started to form, the idea that you can build companies that rival these large conglomerates, and then the airlines' perception of these new technologies being, even though it's a risk, but the ability that if it does happen and it does enter the market, that it's just complete game changers to the entire business.
With Boeing's publicly reported problems, I'll stay publicly reported because they've been widely reported. We don't have to go into great detail. They've been widely reported. There is, in some circles, in some investment circles that I hang out in, that Airbus can gain more market share. And there is concerns around going from a duopoly globally, which Airbus and Boeing are, any way you look at it, to an outright monopoly with Airbus. Does that create incentive for the market to explore a new aircraft manufacturer, a new design? Because we've seen what SpaceX, as you referenced to, has done to space. And not to poke or be rude or disrespectful, again, this is public, SpaceX has to go bail Boeing out. So there's a clear path for opportunity. Do you see that for the aircraft side outside of the space side?
Yeah, of course. I think there's been a huge change in CEOs too within the airline industry. So younger CEOs brought in more forward thinking. And I think that duopoly, I mean, there's only two major manufacturers, only three major engine manufacturers. So duopoly is not only on the airframe side, but also on the engine side. Is, what can we do to get, to do something different? Because, again, this is public, but even as they shift from, let's say, like Airbus delivery or Boeing to Airbus deliveries, well, they're being put in a queue and Airbus has all this negotiating power against them. So why, of course, there's incentive financially and there's also forward thinking, as far as ESG targets that they all have is to really rethink of what this ecosystem or industry really needs to look like.
What's the reaction been towards Nautilus from the investor community as it relates to your design and what you're hoping to achieve as you scale up operation?
I think there's been a very positive change during COVID. It was a very interesting time for us because, freight is not really a sexy part of the market for a variety of ways. I'm sure you can relate, but it's such an important artery within the global trade situation that obviously COVID stressed that to the extremes. But at the same time, as freight was really going up, and I think there was a huge aha moment within the investor community that freight is such an important part of this business or just global business, they've also started to pull back investment because nobody knew what the world would look like. And so as our sector started to climb up and we were in the perfect position to really help solve a lot of those problems, the VC dollars were even more skeptical just because of the nature of the markets and the uncertainty of how long this was going to last. Coming out of COVID, I mean, we've had fundraising opportunities and we've been really successful as far as that goes. And, I think it changed the world for the better for us. And I think there's a more deeper understanding of how valuable supply chain companies, especially even with big infrastructure, needed to be created, how important they are to everything.
Without a stable supply chain, the global economy suffers. We learned that unfortunately during COVID. We could learn that on October 1st when 43% of the US ports potentially go on strike, and just validates what you're building. And we need resources, we need new technologies, new companies to help secure the supply chain. I can make the argument to you now that it's a national security aspect. Staying on the investor theme, what are the economics going to be of Nautilus when you're fully operational and fully commercialized?
As a business, we look like design, build, and sell our airplanes. We've thought about doing operation. I think in the smaller, when people think about drones, most companies would tend to operate their aircraft as well. And then they become fully integrated, which is very interesting. And so profit margins are a lot higher. But what's really unique about us and the larger aircraft is that there's a lot of certification barriers just in the airplane in itself. And then to operate an airline is another certification barrier. And it's operationally very different and very challenging than like a Boeing lookalike. So I think we've talked with a lot of investors about what it takes to vertically integrate, whether we want to be an airline as well. And we've kind of shied away from it. Just, it feels like there's too many risks in of itself. We keep getting the example of SpaceX, they're vertically integrated. Well, I think, there's not a lot of airlines that operate rockets. So I think they kind of had to fall into that space as far as that goes. And then also, I just learned this as a fact, but United actually and Boeing used to be one company. Boeing had an airline, and that was United Airlines. But it was so monopolizing, or I don't even know if that's the word, but monopoly-like, I guess is the better word or phrase, where the United States government stepped in and they had them divest United out. And so I don't think, the United States even government is ready for a fully integrated manufacturer in an airline as well. So I think we're kind of sticking with the design, build, sell model. And it's a pretty good business, I would say, in of itself. You can take a look at, what the Boeing profit margins are. It's about 20% on the commercial side. But some of these airplanes are hundreds of millions of dollars. So 20% against that kind of business is a pretty good business if you can actually get there. So, and then on the airline side, it could be 4 to 5% operating margin. So airlines are not a really strong business. And I think there's a lot of government support and subsidies and really the conversation about fuel that goes into those types of businesses. But I think that's why with those types of low operating margins, it goes back to the cost side of things, is if you can create a solution or if there is another solution that is more operationally efficient, that you can really move a needle on those 4 to 5% operating margins, it's of course very exciting.
Design, build, sells the right model. You don't want to operate an airline. I have a friend that ran a major airline. You don't want to operate a major airline.
That's not a business that I ever want to be in for now.
From the design and the manufacturing, you're based in San Diego. I'm assuming that's where your design will be. Where are you planning to manufacture the aircraft?
We're in San Diego for a reason. There's actually used to be an old aircraft manufacturer here called Convair. It got folded into, I think it was McDonnell Douglas, and then after that it became Boeing. But part of that whole Boeing conglomerate, and they pulled out of San Diego. So there's a lot of infrastructure that exists here. There's actually a world-class wind tunnel, which is right at the airport, about 5 minutes down the street from our office, which we use all the time. And then there's a lot of really big airfields with lots of runway space. And so we're at Brown Field, which is about 15 minutes south, close to the Tijuana border, 8,000-foot runway. So you could almost land a 747 on it with large hangar spaces. And so we have a prototyping facility there, which we're building the first freighter, the Kona regional airliner over there already. And that's about 30% complete. And then as we scale up, we're looking at, staying here in Southern California, but, for a lot of, I would say, political and economic reasons, that might not make sense with large scale manufacturing. And so we've started to explore other opportunities here in the United States as well as abroad, as far as how you build up the supply chain, not being so vast like what Boeing and Airbus has, because I think there's a lot of inefficiencies there, but maybe leaning on 2 or 3 key players, and then a very, very tax incentive friendly state or city that will help us scale up in manufacturing and really create jobs in that region.
There's 2 states that come to mind that would welcome you. I live in one. We're recording in one, Florida. And the other one is Texas. They want the jobs, they want the manufacturing, they want the innovation. If you look at Cape Canaveral on the space side, if you look at Florida has big aviation, Texas has more manufacturing jobs than you and I could both think of right now or calculate. It's really, truly great. From an operational standpoint, since your Nautilus will be autonomous, how do you design that? How do you test it? And most importantly, how are we going to go through an FAA certification? Is it going to be a type 2 certification, or what type of certification, when you eventually get there, will you have to go through?
Maybe it's closer to narrow the conversation down around the Kona, the regional freighter. So that one is designed around 19,000 pounds or less, which fits into the current FAA Part 23 limit, which is general aviation. Everything above that is Part 25, which would be your Boeings, Airbuses, Embraers, Gulfstreams, and the like. So those are really a lot harder, heavier lift to certify. We are under general aviation. The performance of our airplane is actually pretty low compared to other airplanes in that class, because we also have high performance business jets carrying up to 7 to 10 people. And so our certification basis is tied to performance and how many folks we carry on board. And when you really think about who is on board that airplane, well, zero. There's actually, zero risk to human life on board the airplane. And then the second piece of it is, what is the kinetic energy of that airplane? And even though we're large, being 19,000 pounds right at the mark, our speeds are quite a bit lower. They're somewhere close to about 250 knots. And so we actually fit into, I would say, like a Cessna type category for certification, which is very unique. And then the Part 23 paperwork today, in 2013, they opened up large unmanned aircraft certification basis, which is an advisory circular, which allows you to essentially complement the aircraft certification with an unmanned certification. And so all of that kind of existed in a nice little package for the last 8 or 9 years. And so we've been working closely with the FAA. They're mostly interested on systems on board. They know that we can build airplanes, because that's been our kind of pedigree as a team. Just a question of how much redundancy do you have, and the autonomy portion to create the safety net that the FAA really needs to be able to certify the airplane.
How much redundancy is the FAA requiring? Is it similar to passenger vehicles where you need to have two of everything, or is it, since you're in the sky, do you have to have three or four, or are there critical mechanical elements in the plane that they're requiring multiple forms of redundancy versus another piece of equipment on there?
It's typically two right now, based on the certification basis. As they would say, no single point of failure could result in a loss of flight. And so you kind of can walk yourself which those redundancies look like. But, I think from the unmanned portion of it is specifically tied to the satellite communication links on board the airplane. And so we have the ability to shift between constellations. So if we lose one constellation for SATCOM, we automatically switch to a second one and then reacquire the signal. So those types of redundancies that are playing a very important part in our conversation with them.
Why did you make the decision to go autonomous for the Nautilus Kona?
The decision was twofold. First of all, there's a huge lack of pilots entering the workforce. And so as passenger traffic is doubling over the next 20 years, we just don't have enough pilots to fly these aircraft. And so, first flight was 1913, first autopilot was 1930, almost like 15 years after we had this technology. And so it's just been waiting for the regulatory environment to accept that there's a fundamental problem in the workforce. And of course, nobody wants to fly freighters. They want to fly the passengers because it pays better. And so the workforce is shifting. And so then a lot of our future customers, the airlines, are starting to think, well, how can we use technology to solve this workforce problem? It's not really an economic problem for them, as far as pilots cost a certain amount. There's something there, but it's not insurmountable to the fuel or the maintenance of the airplane. It really comes down to can actually hire enough pilots to help meet the global demand of e-commerce as we start scaling that up without losing all of them to the passenger side.
You're right. There's all this talk about a growing labor shortage across most industries, but you said it, and there's public data again to back it up. There's a growing pilot shortage, and being a pilot is a hard life. You're not home a lot of the time. You're on the road flying, as somebody who does it too much all the time, really. It's fatiguing. It's tired. I can imagine sitting in the cockpit. It's probably more fatiguing than flying all the time. When you're designing the autonomous aircraft, how does the design change? Are there certain performance elements that you can get out of it with it being autonomous versus having to make it for human flight?
Absolutely. I think it comes down to life support systems on the airplane. Things like air conditioning is an example. Maybe the cargo needs something as far as but it's not as much as the pilot in the cockpit. Obviously, there's no tray tables for food or, refrigerators for them as far as that goes. No sleeping quarters, so we open up more space and volume within the airplane specifically for freight. It's usually the ancillary things around the pilot. There's certain air crash worthiness standards too that you can kind of walk yourself out of, because, air crash worthiness, I think we were talking about, it could be like 18 Gs on a seat for a pilot. And so, well, that's a lot of structure and a lot of weight that you're carrying for 18 Gs. But I mean, that cargo is already insured. If you crash it, it's cargo. The insurance will cover it. And so you can eliminate a lot of that structure. So you're buying yourself little efficiencies throughout the design that kind of do sum up to be something that's very unique. And then the certification standards actually become less of a heavy lift as well. So it's faster to certify. And so a lot of our conversation is specifically focused on the remote links and the redundancies within the autopilot system and less the airframe side of the conversation.
As you scale and bring on the horizon in your trans-Pacific aircraft, will those also be autonomous as well?
I think there's opportunities to certainly do that. I think the FAA is really watching the smaller general aviation market where the first Kona regional freighter fits in to see how that technology develops. And so can you actually move it into the larger passenger world? A lot of our customers are really bullish on that because, that's when they have 3 or 4 pilots on an airplane just sitting there and sleeping and watching movies for 12 hours. And so if they can eliminate a lot of that, I think it creates a certain amount of opportunities. But I think, again, everybody's watching the smaller general aviation market and seeing how our first product, as well as maybe the eVTOL space with a lot of that autonomy is going to play out.
Hypothetical, if your Kona and your Trans-Pacific were able to go fully autonomous, FAA certified by the European Union's regulator, would they be capable of in-flight refueling so you can really go that extra distance?
They could be. I think right now, especially with the larger airplanes, they have range for days, and the infrastructure exists already where you don't need to go these really, really long routes. I mean, I think even the larger airplanes with maximum fuel can go up to like 7,500 nautical miles, which is just, it's crazy. I think it's like a 16, 18, 20-hour flight or something like that. I mean, not a lot of applications, I would say, given the current networks out there. But of course, the DoD is very interested in those types of capabilities. And so I think it's more of DoD applications that would gravitate towards that. And of course, we're always exploring new business verticals as a company.
What type of fuel are you going to operate these? Are you just airline? You're going to go hydrogen? Where are you going to go from a fueling perspective?
So we're Jet A SAF to start out with, which is very important for us because, I mean, there's a saying within Skunkworks, you never put a brand new engine on a brand new airplane. I think that's wholly true. And so I think, starting out with Jet A and traditional turboprops and turbofan engines is a really good starting point. The infrastructure exists, it's a known technology. And so the only thing that you have to do during your sales cycle is really prove out that the airframe is providing so much value to the customer that they can take a risk on it. We do see, of course, aviation being a really large ESG problem. And so, of course, the investors and customers are always looking for more exotic solutions, I would say, to the sustainability problem. And so we're partnering with Zero Avia, which is the leader in hydrogen propulsion, to really explore what we firmly believe that sometime in the future, hydrogen will be a part of it. Just a question of when, I think, is the answer. But our airplane offers volume, and so hydrogen is very volume centric. And so for hydrogen specifically, if you believe in hydrogen, you have to believe in blended wing bodies. And if you believe in blended wing bodies, you have to believe that cargo is the first section. If you believe in cargo, well, it's kind of like Nautilus that might take the lead in really developing hydrogen-centric solutions as for the airline industry is kind of the first, I would say, beachhead within the entire sector.
I'll give you a lot of credit. You took a grounded approach. There's a lot of founders that I've spoken to that jump right into hydrogen, jump into battery. I was actually talking to a hedge fund gentleman today, and the lowdown that he gave me on the hedge funds on the batteries, they're not going to work for aircraft based on this hedge fund report and what he was telling me. But you made, because of the degradation, but you made the key decision, not, I'm going to use this term to be very blunt, not to be stupid and not to leap into something, to go for Jet A. Is that because you're sitting here wanting to build a business? You're saying, okay, our core competency is building an aircraft, not necessarily building the engines or building the fuel source. Is that why you did that?
I think that's kind of the first decision. And then just risk. I mean, not only our investors, but our customers. I think it's really hard to sell a high pie in the sky idea. I know certain people have done that, but it's just, you want to create customers. You want to create that for customers. You want to get customers, so you can get investors. Investors will allow you to build the business. The business allows you to scale and actually create the solution into the market. And I mean, honestly, Tesla did a great job with the Tesla Roadster and bringing a Lotus Elise airframe to start out with. Obviously, then they kind of grew out of it as they learned about it. But I mean, for us, I don't think the complexity with developing an engine with an airframe, and then even the other thinking of going into an airline business is just, it's insurmountable. And so just starting with what you know best and kind of going from there.
Start with what you know best is a really great transition for this curiosity. How many Konas are you planning to manufacture over the coming years? You can start with one, prototype it, or what does your manufacturing scaling plans look like?
So right now we have an order for over 420 of the Kona airplanes with major airlines across the world, which is a pretty good number considering we're a startup. Right now, capacity is tied to about 5 airplanes per month, and obviously can scale up, scale down based on the demands and needs of the market. But at airplanes per month, it's a very simple general aviation kind of facility. There's a lot of those facilities already kind of available in the United States, as an example. Some companies went under. And so you can kind of walk yourself into those facilities without building up major infrastructure. So that's kind of the way we've been thinking about it is 5 airplanes per month gets you a facility that is known and understood.
What numbers are going to take to achieve to where you start to reach the benefits of scale from a cost perspective? Is it 10 aircrafts a month, 12 aircrafts a month? Where is that going to come?
Actually, I think the break-even point we looked at it's really it starts at 2 or 3 airplanes per month is when you start to see the learning curves really come down and the price to produce an airplane to be really meaningful, where you can actually capitalize on the revenue that you really need at that point because you've sunk in so much development dollars in the first place.
What's the projected cost when you go to sell these to your customers?
7 to 10 million is what we're projecting right now.
So that doesn't seem too out of whack. What's the payback period for your customers?
Payback period. I mean, it depends if they own it and pay in cash or they lease it, or meaning leasing it as far as financing it. So I think those are two different business models that a lot of our customers operate on. So and then it's just based on the leasing options. If they buy it out in cash, they can essentially start making money day one, provided that they have it.
Well, that's really so. Then you'll partner with a jet leasing fund essentially and sell it to them. Then they'll go lease it to, say, commercial shipper one, commercial shipper two, that type of model.
It kind of was surprising to me, but I think Ireland owns like 80% of the world's airplanes. It's just because they finance it all through Ireland. And so even major airlines, they would buy something in cash, but a lot of them would hold cash on their balance sheet and typically choose to lease or refinance their assets.
You understand the business. You understand the financing aspect because you understand how to manufacture an aircraft. What was the inspiration for Nautilus? Did you read a Jules Verne novel one day, perhaps Around the World in 80 Days, and said, we can do that shorter and we can do it for free? What was that inspiration?
I'm a big Jules Verne fan. We can definitely talk about that in a sec. But the inspiration was I got out of aviation and aerospace and started an industrial design studio. So back when iPhone cables were 3 feet long, we were one of the first companies to make them 6 feet long. Seems so obvious right now, but I don't know why Apple didn't do it at the beginning. So you can maybe tell it to Apple. Apple was the inspiration and their mess up on the cable length. But we started an industrial design studio, went through a Kickstarter successfully 3 times, doing a variety of consumer electronic products. And we would do the design. It would take us maybe an hour or two in the United States, and then we would ship it over to Asia for manufacturing, and then it would hit distribution shelves and things like that. And we had a direct pick to ship to all our consumers. So that grew to be a pretty good business, and we were having so much fun doing it because airplanes would take a decade sometimes to bring to market, and then these cycles would be a couple of days sometimes before you actually see the product and you can actually hold it in your hand. And so that got really exciting for us, but we were just always challenged by the supply chain issues of bringing products over from Asia on the manufacturing side, especially as we would land a retail contract. They would want the product to be available in a week, already packaged in their warehouse. And so we'd be tearing our hair out, and then we would end up splitting the loads between air freight and ocean. Of course, air freight would eat a lot of our lunch on the product development and the manufacturing. And so we'd have to make it back up on the ocean side. And so we were kind of wondering, like, why is this such a problem? And so that's why we leaned back into our aviation background and thought, well, maybe if you do this, and this, you can move the price points for especially trans-Pacific transportation to a point where you kind of commoditize air freight. And if you commoditize air freight, well, a lot of things start to become very interesting. And so we thought we had this one great idea, even though a successful business. And so we used that as kind of like the tipping point in Nautilus, started cold emailing investors in San Francisco, and a lot of them latched onto it, surprising enough. And so we had to sell off the company and got our first seed check and really went after it. But to your point, the name Jules Verne I was a big Jules Verne reader and still a big reader today, but 20,000 Leagues Under the Sea, Captain Nemo, of course, Nautilus is the name of the submarine. But in the original text, not a lot of people know, there's actually a very maybe one of a kind graphic where it's Captain Nemo in, I think, somewhere in the Antarctic, claiming that as his land. And then in the flag, it said Nautilus, and it said movement within movement in Latin. And I always kind of gravitate towards that saying as movement within movement. And so as the airplanes shift in configuration and shape, I thought it was a very fitting possible name for a company.
It's fitting. The story's fitting because you're taking all the pieces of your life experience and putting it together and following the path that was laid out in front of you. That's what all the great entrepreneurs do. They put the pieces together and they see it. Aleksey, what's the future of Nautilus?
Well, we have some very exciting announcements coming up over the next 4 to 6 months that I've been counseled very heavily to not talk about. So I'll kind of say that there's some exciting announcements coming up. But, I say over the next 2 years, we'll see the first flight of the world's first blended wing body at full scale. I think that'll be an aviation first worth celebrating as a whole, which hopefully will produce the efficiencies that we've been seeing in the wind tunnel, and then obviously get our customers excited and ramp up production of facilities. And then it's really the second and the third airplane where we really make a mark, is getting after those longer range routes, carrying heavier payloads, and really starting deliveries to customers to show that we are a real company. And then we can play on the same field as the likes of Boeing, Embraer, and Airbus. And so I think that'll be a very exciting journey for me. And the team behind me too is just thrilled about it. And it's such a fundamental problem that is so overlooked. So yeah, we're excited to be tackling it.
You're securing the supply chain. When you take flight, perhaps we'll come out and we'll shoot a video and do a podcast there with the plane in the background, because without a strong supply chain, we do not have a strong global economy. Aleksey, before we take flight, what would you like our listeners and viewers to take away with them today?
From an entrepreneurship perspective, if you see a problem, especially in your personal life that you think is worth solving, I think there's definitely opportunities with that and venture capital. I think we're kind of one of those I wouldn't say few, but very numerous stories within Silicon Valley as far as doing that. The second thing is we're always hiring. So we're looking for great engineering talent, especially if they're willing to move to beautiful San Diego. I think it's a great opportunity.
If you want to build the future of flight, join Nautilus. The future is bright. The future is autonomous. The future is Nautilus. Aleksey, thank you so much for coming on the road to autonomy today.
Thank you for having me.